Welcome back to the Savage Sullivan Math website. Today we're going to continue looking at systems of equations and solving them by graphing, but today we're going to also look at some special cases. So the first system that we're going to use is 2x plus 3y is equal to 4. And then we're also going to use the equation of 4x plus 6y is equal to 9. If you notice, both of these equations are written in standard form, so we need to change them to slope-intercept form. So for the top one, I'm just going to label it blue so we can tell the difference. We've got 2x plus 3y is equal to 4. We need to change that to slope-intercept form. We're going to subtract the 2x from both sides, and we're left with 3y is equal to negative 2x plus 4. Then we need to divide everything by 3, and we are left with y is equal to negative 2/3 x plus 4/3. It's going to be a fun one to graph. We've got our y-intercept of 4/3, so we come up here to 4/3, and then we've got a slope of negative 2/3. So down 2 to the right 3, down 2 to the right 3, or we could go up 2 to the left 3. Connect your dot. Our second equation is also written in standard form, so we're going to change that one to slope-intercept 2. We've got 4x plus 6y is equal to 9. So we subtract 4x from both sides, and we are left with 6y is equal to negative 4x plus 9. Divide everything by 6, and you're left with the equation of y is equal to negative 2/3 x plus 3 halves. Y-intercept of 3 halves goes right here, and then again our slope of negative 2/3. So down 2 to the right 3, down 2 to the right 3. You'll notice that our lines are very close to each other, but they do not intersect, and they never will touch, because their slopes are the same, but their y-intercepts are different. So we would say that these two lines will never find any points in common, and therefore there is no solution for this particular system.
So now we're going to look at an example that's a little different, but it's still a special case. So we're going to start by graphing the line y equals x minus 1. So our y-intercept is negative 1. Our slope is positive 1, because there's an invisible 1 there. So we're going to rise 1, run 1. And same down here, opposite way. And draw your line, arrows on the ends. Before we're able to graph this one, we have to get it into slope-intercept form. And in order to do that, we only have to do one thing. So we're going to divide both sides by 3. And when we do that, we'll have y equals x minus 1. And that should look familiar because it's identical to our first equation in our system, which means when I go to graph it, the two lines are going to lie directly on top of each other. So if we think about what it means to be a solution to a system, which is where the two lines intersect, these lines intersect at every point, which means the system will have infinitely many solutions. Which is different than saying all real numbers, because if we say all real numbers, that means that any number would work. But here, it's only the numbers, only the coordinates that lie on the line will work in